Hey guys, so today we're going to talk about scientific notation. Scientific notation is just a way to write big numbers in a much more compact way. So, what is scientific notation? Well, scientific notation is expressing numbers in terms of powers of 10. And what do I mean by that? Well, in most cases we would take a really big number. Let me get a marker that works. We would take a really big number and turn it into a really small number times powers of 10. So for example, let's work our way backwards first. So we have the number 7 times 10 to the third power. What does that mean? Well, 10 to the third power is 1,000. So we have 7 times 1,000, or 7,000. Alternatively, we can write it another way. So we're going to go backwards. So we know that 7,000 is equal to 7 times 10 to the third power. So when we have a really big number, like let's say 25 billion, and we don't want to write that out dozens of times, we can simply compress that to another number. So let's talk about how to do these, and then we'll go back to this one. So, to convert this number to scientific notation, what do? The first thing you want to do is find the decimal point of the number. So, for 123, the decimal point is back here. So, what you want to do, you want to go behind the first significant digit. If you're not sure what significant digit is, we're posting a PowerPoint about that as well. So, the first significant digit here is 1. So we're going to go and move the decimal points behind the 1. So 1 jump, 2 jump. So we have 1.23. The number of jumps here is what your exponent on the 10 is going to be. So this would be times 10 to the second power. So let's double check that. 10 to the second power is 100, because 10 times 10, times 1.23. And that gives us back to 123. So we know that this is proper scientific notation for 123. 1.23 times 10 to the second power. So let's move on to this one, which I've written wrong. We have 7,500,000. So we're going to do the same thing. We find our decimal points. For here, it would be right here. We're going to go 1, 2, 3, 4, 5, 6. Okay? Now we have 2 significant digits here. So we're just going to write those. So 6.5 times 10 to what power? Well, we went 1, 2, 3, 4, 5, 6. So this would be 6.5 times 10 to the 6th power. All right, what if we want to do it in reverse? Well, we're going to have the same concept. So we have 0.05 here. So we find our decimal point, it's right here. Then we're going to jump 1, 2. So, going off of that, our first significant digit is 5. So we're going to write 5 times 10 to what power? Well, we went backwards 2 jumps. So when we go forwards, we have a positive number. So when we go backwards, we have a negative number. This one will be negative 2. So 0.05 is 5 times 10 to the negative second power. Let's do this last one here, right, before we do this one. So 0.00000174. We'll put that in scientific notation. We're going to do the same thing. We're going to 1, 2, 3, times 6. So our sigma units here are right here, same for this one and this one. So we have 1.74 times 10 to the -1, -2, -3, -4, -5, -6th power. All right, lastly, let's just do this one. So 25 billion. So we found our decimal point right here. We'll be jumping forwards with this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our sig figs are 2 and 5. So we have 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th power. So it's fairly simple once you get the hang of it. It's just the trouble of getting the hang of it first. So, scientific notation, we're simply compressing numbers into smaller forms by putting them as smaller numbers times some power of 10. And that's basically it. You all have a good day.